Hey everyone, good morning. I hope you are enjoying your snow days or whatever you want to call these last 3 days of not having school. Your title today is Intro to Factoring, and this is our first flipped classroom lesson. So if this is something you like, maybe we can incorporate it more into our general routine. What I'd like you to do is to find the factors of these numbers listed here. And remember, what factors are numbers you can multiply together to obtain a certain product. So thinking about numbers you can multiply together to get 12, 18, 6, 40, or 31. Go ahead and pause the video, and I want you to see if you can figure that out on your own, and then hit play when you are ready to see the answers. Our factors of 12 are 1, 2, 3, 4, 6, and 12. 1 and 12, 2 and 6, 3 and 4. If I multiply any of those together, I would get 12. My factors of 18 are 1, 2, 3, 6, 9, and 18. My factors of 6 are 1, 2, 3, and 6. My factors of 40 are 1, 2, 4, 5, 8, 10, 20, and 40. And you may have noticed your factors of 31 are very simple, just 1 and 31. And that is because 31 is a prime number, and that means its only factors are 1 and itself. So hopefully you did an all right job at that. Knowing how to find factors is going to be very useful in this unit. And if you need some practice, you always know you can come at lunch or ask me for some more help. What we're doing today, we just talked about factors. We're going to learn about factored form, the zero product property, and zeros of a function, a quadratic function. And by the end of the day, you'll be able to identify zeros of any quadratic function that you are given if it's in factored form. Your work session is going to be considered your homework, which will be due on Monday. And I know that's not the usual day we have homework due, but these circumstances of these snow days are not usual. So this will be due on Monday. What I'd like you to do is go to desmos.com/calculator. That's just the general graphing calculator site. And I want you to graph y equals x plus 4 and y equals x minus 2. And I have that pulled up on my screen right here. I've graphed both these lines, and these are just regular linear lines. As you can see, they have a constant rate of change. There's no curve to them at all. They're not exponential or quadratic. So if you look, I've highlighted the x-intercepts of both lines. So of the red line here, which is y equals x plus 4, I notice I have an x-intercept of negative 4, 0. My x-intercept's negative 4. On the blue line, or y equals x minus 2, I have an x-intercept of 2, 0. My x-intercept there is 2. Now, if I wanted to take these two linear lines and I wanted to make a quadratic function, all I would have to do is multiply these two linear factors together, which is what I've done here in this line. And if I show you that, if I unblock it so you can actually see the line, you're going to notice that you have a parabola there. You have that quadratic curve, the parabola. And you'll also notice that the x-intercepts of the parabola are negative 4 and 2, just like they were for the linear lines. So if you notice the x-intercepts, we can actually predict what they are just by looking at the linear factors that we've been given for a quadratic function. So that's what we're going to explore today a little bit. So again, we're going to look at x-intercepts. If you hear the word zeros or solutions or roots, all of those terms are interchangeable in this unit. If I ask you to find the zeros of something, it means to find the x-intercepts. If I ask you to find the roots of something, it means to find your x-intercepts. Keeping in mind, our x-intercepts will be located here on this little sample graph that I've drawn for you. And if you want a definition of what a zero of a function is, I have that here. A zero of a function is an x value that makes your y value equal to 0. So again, we're looking for what numbers would result in a 0 for our y value, because we know that if we have a 0 for our y value, then we're going to find our x-intercept, or x comma 0, whatever that x is. So before we start looking at some examples, we have to learn about this form we're going to look at. And this is the last form we're going to learn of quadratic equations for this unit. And this form is called factored form or intercept form. You'll see that used interchangeably as well. For factored form or intercept form, the equation is as follows. It's f of x equals k times x minus a times x minus b, where that A and B value are going to be considered your x-intercepts, and your K value cannot be equal to 0. That should have a not sign equal, or a not equal sign in it. K cannot equal 0 because if it was equal to 0, we know we wouldn't have a function at all, because anything multiplied by 0 gives us 0. We wouldn't have a line at all. That would definitely be important to write down in your notes, that last form. You'll also see this form located up here for the rest of the unit. So be mindful if you ever forget standard form, vertex form, or factored form. They're listed right up there. So today what we're going to use is something called the zero product property. And what that says is if the product of two quantities equals 0, at least one of those other quantities must be 0. Just take that little plurality out. So what this basically means, if you have a number A times a number B and it equals 0, then A or B has to be 0. So basically what this is saying in regards to what would be valuable to us is we have to figure out in our quadratic equation, if we wanted a y value to be 0, what would our x values have to be? That's what we're figuring out here. We're figuring out our x-intercepts, which again we just talked about, are when we have an x value and a y value equal to 0. So let's do some practice with this. Let's look at our first example here. So here's a quadratic equation, f of x equals x plus 4 times x plus 5. And in order to figure out where this quadratic function is going to cross the x-axis, we have to set the equation equal to 0, keeping in mind that f of x is equal to y. So we're literally setting y equal to 0, which will help us find those x-intercepts. So here we've got 0 equals x plus 4 times x plus 5. And according to the zero product property that we just learned about, if we have some quantity A times some quantity B equal to 0, we know that either A or B has to be 0. So we need to figure out what x values are 0, or what x values exist that make this function equal to 0. So what you do is you set each linear pair equal to 0. So let's try that. X plus 4 equals 0, or x plus 5 equals 0, because again, what this means is that one of these factors has to be 0 if we want a product of 0. So let's figure it out. In this case, to solve this equation, we subtract 4 from both sides, and we would have x is equal to negative 4. And in this equation, we would, to get x by itself, we'd subtract 5 on both sides. We'd have x equal to negative 5. So what this means is our zeros, where our y value is 0, where our x-intercepts are, we know are at negative 4 comma 0 and negative 5 comma 0. So if we were to graph this quadratic equation that we just looked at right here, this one right here, we know that we would have the cross at this point right here and this point right here on the x-axis. So it's kind of cool. You can find out, again, a lot about parabolas just by looking at them in different forms. So let's try another example. We're going to do 2 more together, and then I'll kind of set you free on your own. Let's try these ones, for instance. So again, our quadratic equation we're going to look at, we have to set it equal to 0 if we're looking for our x-intercepts, our x comma 0. So my f of x I set to 0, because remember that represents y. So I have 0 equals 4 times x minus 8. Let's set both of our factors equal to 0. So here I have 0 equals 4, and that is not true whatsoever. So we know we don't even need to worry about that, because that's not a true statement, and we know that 4 is not going to be a factor in this case, or excuse me, a x-intercept in this case. But let's set the other one equal to 0. X minus 8 equals 0. Add 8 to both sides, and we're going to have x equals 8. So we know that this equation right here has an x-intercept of 8 comma 0. And it's interesting because it only has 1. And the reason why it only has 1 is because this is not a quadratic equation. It's just a linear one. We don't even see an x squared. Let's try this one right here. Again, we're going to set my y value equal to 0 because that's how I find my x-intercepts. So I have 0 equals x times x plus 2. Let's take both factors and set them equal to 0. I have 0 equals x and 0 equals x plus 2. With this one, that's great. I have no solving to do. 0 equals x, so x must be 0. So I know that one of my x-intercepts is 0 comma 0. Here, if I subtract 2 on both sides, I know that x would be equal to negative 2, so I know another one of my x-intercepts is negative 2 comma 0. So again, I can get a picture of where this parabola is going to cross the x-axis, which is going to be really helpful when we start looking at questions that have to do with projectile motion. If someone is throwing a football, what time do they start throwing the football? What time does it actually get caught? Lots of different things. So these are really important to know. What I want you to do is pause the video and I want you to try figuring out these 3 equations. Try and find the solution to these. And remember, when I say solutions, we're talking about x-intercepts. What are the x-intercepts of the following equations? Remember, use the zero product property to set the function equal to 0 and then figure out your x-intercepts from there. Go ahead and pause the video and try it. And when you're done with the 3, come on back and see if you're right. So for our first one, we have 0 equals 3 times x minus 4 times x minus 2. We have to set each factor equal to 0. 0 equals 3. All right, that's not true. So I know that's not one of my x-intercepts in this case. 0 equals x minus 4 and 0 equals x minus 2. With some really simple algebraic steps, I can figure out that one of my x-intercepts is 4. And another one is negative 2. So I know my 2 x-intercepts for this parabola are 4 comma 0 and negative 2 comma 0. Remember, I don't need to consider this one because 3 is not equal to 0. Let's try this one. I already know if I set this equation equal to 0 that I don't really need to worry about this 2 here because 0 does not equal 2. So I'm just going to look at where I have possibilities to get an x-intercept. So here I'm going to set 0 equal to x plus 1 and 0 equal to x minus 9. So I subtract 1 on both sides. Here I'm going to add 9 on both sides. And again, all I'm doing is solving for x. These are basic one-step equations you've been doing since 7th grade. Negative 1 equals x, and on this side 9 equals x. So that means my 2 x-intercepts are negative 1 comma 0 and 9 comma 0. Our last one that we look at, if I set this equation equal to 0, I have negative 4 times x plus 3 times x plus 5 is equal to 0. I know that 0 does not equal negative 4, so I'm just going to set 0 equal to my 2 linear factors that I have. I know I just wrote that one in parentheses. It doesn't matter. Subtract 3 on both sides, and on this one subtract 5 on both sides. Here I find that x is equal to negative 3, and on the other one I find x is equal to negative 5. So my 2 x-intercepts are negative 3 comma 0 and negative 5 comma 0. And if you don't believe yourself that those really are the x-intercepts, go on Desmos and graph that, and you'll find that those really are the x-intercepts. The last example we're going to do together just combines everything we've done, not everything, but a lot of things we've done so far in this unit. If we look, I want you to try to find the x-intercepts of this quadratic equation, then I want you to convert it to standard form. So if we find the x-intercepts, I'll do that off to the side. Go ahead and pause the video if you want to try it on your own. The x-intercepts here, we've got x plus 5 equal to 0 and x plus 1 equal to 0. Through some simple steps, I know that x equals negative 5 and x equals here negative 1. So my 2 x-intercepts are negative 5 comma 0 and negative 1 comma 0. Here, if I wanted to convert this to standard form, remember standard form is right up there. So we have to convert it to the form ax squared plus bx plus c. First thing I'm going to do is I'm going to make an area model for this binomial multiplication right there. So I've got x plus 5 and x plus 1. When I solve that, I get x squared, 5x, 1x, and 5. Rewriting my quadratic, and again, I'm going really fast because I'm almost out of time. I've got x squared plus 6x plus 5. Multiplying my negative 2 to each term in the parentheses, I have negative 2x squared plus, minus 12x minus 10. And what's really cool about this standard form is you know that my y-intercept is 0, negative 10. So again, you have more pieces of information you can use to help you figure out what this parabola would look like. All right, y'all are onto your work session now. Go ahead and check Canvas to see what that is. Watch this video again if you need some help. Good work today.